Alright, so Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good evening, everyone. So welcome back to our lecture time slot, and today will be our last lecture um, for the subject under subheading proteins slash peptides and lipids. Um, so gonna look at introduction to lipids part 2. Okay, so last week we've looked at a little bit on what are lipids and the different categories of lipids. Okay, so today we are on week 12. Okay, so we have two lectures, one today and the final one will be on Thursday. But as I mentioned, I'm gonna use the lecture on Thursday to actually do a little bit of a quiz. We'll do like a very quick quiz online. Okay, so I want everybody to be you know in the Google Meet group again. Okay, I'm gonna post the questions there. So the aim is to have about 10 questions, particularly on the subject of lipids. Okay, and then following that, so the quiz will take about 15 minutes or so. It's a very quick one, and then following that I'm just gonna open for Q&A for your assignment. Okay, so because we are on week 12 now, we have 2 more weeks before the end of the semester. Therefore, I'm hoping that you guys have started a little bit. So, I actually force you guys to write something. So at least you have that for your submission if you don't have any other time to do it. Okay, so we're gonna look at more on lipids, but unfortunately we will not be looking at that per se. Okay, because towards the end of the day we don't have any final exam, so I'm thinking of doing more of a basic introduction to the subject of lipids and then focus more on your assignments. Okay. Alright, so last week we've looked at lipids and the two different categories. We have fatty acid and steroids, and then we also looked at waxes and triglycerides or triacylglycerides. However, by mistake, I actually did not touch about the group number 3, which is glycerophospholipids. I probably mentioned about it, but I didn't actually have a slide on it. So we're gonna look at that firstly, and then following that we'll look at steroids and the subsection for steroids, which is example cholesterol and steroid hormones. Okay, so glycerophospholipids. So what are glycerophospholipids? If you look at the structure over here, it's pretty much kind of like any phospholipids. If you have learned anything about cell membrane, you must have accounted the words phospholipids. So just that one, phospholipids. But over here, we are actually integrating glycerol with the phospholipids. So phospholipids normally is just that section over there. Okay, link by a different way, or probably it's a similar thing, but you don't really say, or biologically you normally don't say the glycerol part. You just mention like phospholipids, and phospholipids in our cell membrane is normally you have one phosphate and then two lipids chain. Okay, but glycerophospholipids is more or less the same, so it's part of a component of a phospholipid bilayer, but we will go through it and we'll see more about it soon. Okay, so it's the most abundant lipids in the cell membrane, as I mentioned, and composed of glycerol connected to two fatty acids and a phosphate and an ammonium alcohol. Okay, so we have two fatty acids, 1 and 2, and then you have phosphate linked to an amino alcohol. So that's the general structure of a glycerophospholipids. So an example, if you looked at amino alcohol, it's basically some which you have accounted before, like for example choline, okay, and ethanolamine, which some of you have used it for your synthesis, and we've also saw this back when we were learning about proteins and peptides. Okay, so we have serine as part of an amino alcohol. If you look at it in a different way, so if you look at from this angle, okay, it's an amino acid. So you have an amine and then you have an acid group, so it's an amino acid. But if you want to look at a different angle, where you have an amine and an alcohol group, so you also have an amino alcohol group. It's short, simplest example. Okay, so a real example of a glycerophospholipids is as shown here. Okay, so you have a polar head, which is normally the phosphate and well, definitely the phosphate and the amino alcohol group link by a glycerol over there, and then you have the nonpolar tails of fatty acid. Okay, so that's the basic structure. And then um, for a cell membrane, normally you have something like this. Okay, so it's arranged in a way that you have um, your glycerophospholipids merging, forming a two, what we call as bilayer. Okay, because we have your fatty layer in the middle and then your polar head group over here. Okay, so this is our cell membrane, the basic structure anyway. It's not the real ones. The real ones are more complex, but that's the basic structure. Okay, so it's a cell membrane, and as you've learned before, that fatty acid can either form a solid like structure, like stearic acid, for example, or it can be a little bit fluid. So our cell membrane, as you imagine, if you've seen one, our cell can actually form different types of shapes. Okay, so it's actually not that rigid, so it's flexible. So what makes it flexible are this structure. Okay, so you have something like a unsaturated fatty acid over there. Okay, so as you learn again, when you have an unsaturated bond, the physical properties of the oil or the lipids are becoming more like an oil like. Okay, so it's flexible, it's fluid. All right, so another example of glycerophospholipids, lecithin. Okay, so have you heard about this? If you have not, what you can do is try and find any junk food that you have at home, and read about the ingredients. Okay, so some of you, well, some of them might have written as soy lecithin, or I can't remember the code. I think it's E110 something. Okay, so it's basically it's kind of like an emulsifier again, because you have a polar group, remember, a polar group and a tail. So this is what an emulsifier does. Emulsifier, so it emulsifies between oil and water. Okay, so some ingredients, they use glycerophospholipids to make sure that the ingredients are juicy, at the same time it's a bit oily, because that's what Malaysian like. Anyway, but they also use this as I think most of them uses it as emulsifier. So yeah, there you go, emulsifier. So lecithin and cephalin. Okay, so there's two example. Also, it's a major component in the brain. So if you eat junk food, it's actually not really a junk food. So some of the component is actually healthy. So eat a lot of junk food. No, I'm joking. So don't eat a lot of junk food. Even though it says here major components in the brain and nervous tissue. Again, in biology, anything in excess or way excess is bad. So something which is a major component of a brain might be as small as like 1%, or as the biggest is 1%, not small as 1%. Biggest is 1%. Okay, so you can find glycerophospholipids mostly in yolk, okay, in egg yolk, in wheat germ, and in yeast, so bread. And the difference between those two structure is this. So both has one glycerol, yes, but for lecithin you have one palmitic acid and one oleic acid, while the other one you have two palmitic acid, and the ammonia alcohol is different. Okay, so this one is a trimethyl structure, that one is just a normal ammonium. Okay, so you can see that this one is obviously more polar compared to that one. Okay, because this one will depends on the pH. So you can have either a polar uh, charge ammonia, or just simply a neutral ammonia. However, for this one, because it's a trimethylated ammonia, so it's always have a positive charge. So you know that that one has a higher um, polarity compared to the other one. And then, so what's the second one? The second one is you have an oleic acid over here, which cause a kink in the structure. So you know that lecithin is more fluid-like compared to a cephalin. Even though I'm not saying that cephalin is not liquid, no, cephalin is still a liquid solid, way is more viscous compared to the lecithin. Okay, so that's kind of like something that you can ponder about by looking at the structure of any molecule. All right, so that's it for glycerophospholipids. We're going to touch about it a little bit under steroids, because they are related. They are biologically, well, the components are biologically related, some for in one way or another. All right, so steroids. When we talk about steroids, don't just think about anabolic steroids where people consume these anabolic steroids to make sure that their muscle mass is very good, where athletes consume steroids for various other reasons. Okay, so um, it's good to know what are the structure of the steroids, in case in the future, if you're interested in learning more about steroids, or probably discovering about what are other steroids available in the world that might help people in a way of making a drug, or because steroids can also be hormones. So yeah, if you're interested in the future to do some research and whatnot, then you might want to work with steroids. But I'm warning you, steroids are very, very difficult to synthesize. At least the basic structure is okay, but yeah. Alright, so what are steroids? Steroids has 16 carbon skeleton forming the nucleus or the core structure as illustrated down here. Okay, so it has three connected six-membered ring. So you have 1, 2, and 3, and then you have one five-membered ring connected to one of the six-membered ring, which is that one. Okay, so these are the basic structure of steroids. And this one I'm just showing you the basic backbone structure. It doesn't mean that there's no unsaturated bond or everything is saturated. No. So these are the backbone, ignoring all the other chemistry. So these are how the backbone are connected. All right. And it says here there's no fatty acid. It doesn't mean that when it's no fatty acid, it's not steroid. No. Steroid can also have a fatty acid, but connected to part of the backbone. So the backbone itself has no fatty acid. So that's how you differentiate between a steroid and the fatty acid or wax and whatnot. Okay, so that's the basic distinguishable feature. So also steroids can be identifiable by the end term. We have something over there plus own or oil. Okay, so we'll just remember about this, and we will see more example as we go throughout the lecture. All right, so the first example, cholesterol. See, this is what I mean. You have something and then all at the end. So cholesterol, right? So it's part of a steroid, obviously. It can be synthesized in the liver, and it can also be obtained from food intake such as meat, milk, egg, fast food, etc. So highlighted here, fast food, for a reason. All right, so we'll go to fast food later on. So the importance of a cholesterol is first and foremost for cell structure integrity. Okay, so it's part of a cell membrane component, and it's being used a lot more in a nerve tissue. Cholesterol can be biosynthesized, is a precursor for the biosynthesis of vitamin D and other steroidal hormones. Okay, so if we just stop over there, for example, remember when we talk about the glycerophospholipids. Okay, so I draw a structure like this, right? And then I say that because of this, so the structure is a fluid-like. Well, that's actually partly true. Okay, so what you have in the biological system is a steroid components embedded in the middle of the phospholipid bilayer. Okay, so why do we have that? Well, God created us very unique. If you don't have that, then your structure, your cells are even more rigid. Okay, so by having a cholesterol in the middle, you can actually have more space in the middle here for the cell membrane to float around, to move around and whatnot. Okay, and the interesting thing about cholesterol in the cell membrane layer is that um, so it gives out the a high structural integrity for the cell membrane. For example, let's say we take a plant or grass living in a four seasonal climate. So where you have your summer, which is very hot, and then you have something, and then you have winter, uh, which is very cold, and then you have something, and then you have summer again. Okay, so what happened here is that um, say for example, if you pluck any grass from your home, okay, so we can consider Malaysia to be, you know, all year round summer, so which is very hot. So obviously our cell structure, or the biological cell structure, needs to have a more like you know, fluid like. Okay, so because it's warm, so we don't need a lot of cholesterol. Oh, I'm not saying we don't need it, but biologically it's all controlled, so that we don't have a lot of cholesterol in our we don't need a lot of cholesterol in our cell membrane to promote fluidity. But in winter, if you take the same thing that we have on summer and then bring it to winter, it will crash, it will form a crystals. Okay, so biologically, what the plants do is those who actually have a four seasonal, or live in a four seasonal climate, they have increased number of cholesterol in the cell membrane. So this is to make sure that the freezing point is way lower, so you don't freeze your cells. Okay, so that's why say in the future, if you are destined enough or are lucky enough to play with snow, okay, bear it going to New Zealand or the UK or Russia or Japan or whatever, and you can actually see there are plants that, you know, still have leaves during winter. Okay, so they don't die, even though, you know, you might think that everything will die in winter, but there are some plants which did not die during winter. So this is part of the reason. Of course, there are other things that might influence the biological processes, but one of them is cholesterol. Okay, so that's why I said cell structure integrity is very important, to have a cholesterol, a certain number of cholesterol. However, again, you know, even though it's important for cell integrity and then for biosynthesis for other vitamins and hormones, but a high number of cholesterol can promote atherosclerosis, okay, where there's a blockade. If you look at the structure, the figure on the bottom right, where you might have a blockade of a, your artery. So you can have heart attack, you can have sclerosis, you can have a thrombosis. So there's a lot of other diseases related to cholesterol. And so the structure here is showing a formation of plaque in the artery. So normally you do have, it doesn't mean that you don't have at all, because again, your body can synthesize it on its own, okay, synthesize in the liver. So you do have a certain degree, a certain number of a percentage of cholesterol in the body. But having eaten too much fast food, for example, can promote from a normal to a high level of cholesterol, okay, which is bad, and which you shouldn't do. So even though you say, oh, I can exercise and whatnot, but say for example, a student A is not eating fast food but do very minimal exercise compared to student B, which eat very like consume fast food every day for breakfast, lunch, and dinner, but then also did a lot of exercises. Student B can also develop this. Okay, so of course student A can also develop this on this, but the probability is lower, okay, to develop a high. Even though I'm not saying this is impossible, it's still possible, everything is possible. But compared to student B who consumes fast food every day, um, even though he or she might have done a lot of exercises, they can also have this. Okay, so that's why sometimes you hear that people playing badminton and then they suddenly just have a heart attack and whatnot. So it's because of this. So to have a good healthy life, you need to have a balanced diet, okay, and do exercise too. All right, so health limit for cholesterol is about 200 milligram per deciliter or less than 2 milligram per mil. So it's actually like very, very little. Okay, so it's probably about two, more or less, well, 2 mils is not 2 drops. Slightly more than 2 drops, but you get the gist. 2 mils is very little. If you take a syringe, and see, oh well, it's 2 milligram per mil. So more or less, yeah, more or less is about 2 drops, I guess. Okay, and table 15.3 is just showing you the cholesterol content for some food. So a beef for those who actually like to eat liver. So for a serving size of about 3 ounce, which is 84 grams, you have approximately 370 milligrams of cholesterol, which is roughly 0.44% per gram of the beef. Okay, also in eggs, you have roughly 550 milligrams, and I've calculated using an M size egg, so it's roughly about 0.5% of the egg is actually a cholesterol. So that's why some people say, when you eat eggs, please be mindful. You don't consume eggs as if you are consuming rice. Consuming rice, a high amount of rice is still okay, even though it might make you fat or something, or develop different types of diseases. But and even if you're skinny, but you eat a lot of eggs, there is also a high chance for you to develop any other diseases. All right, so these are some other examples of cholesterol, or steroids. Everybody's consuming steroids now. Okay, so another example of steroids. So this I've already talked about it. But for cell structure integrity, this is how it looks like. You can see a steroid hormones drawn, embedded throughout the cell membrane layer. Okay, so these are the glycerophospholipids bilayer, and then you can see in a more cell-like model. So you have not just the lipid bilayer, you do have a glycoproteins, you have carboglycolipids. Okay, so you have proteins embedded throughout. You have cytoskeletons. You have extracellular membrane matrix. So these are all that helps cells becoming, cells, and they are intact. So it's not just about cholesterol or phospholipid bilayer, but it's everything. And for those who are interested to know more about cell membrane, you can Google this fluid mosaic model. Okay, so not gonna touch about this because this is not biology. But lipid bilayer and fluid mosaic model kind of like builds who you are as a person. Okay, that's it for cholesterol, and I'm gonna move on to this final section, which is steroid hormones. So what are hormones? Hormones are chemical messenger. Okay, so it promotes cell to cell communication. Well, it's not the only one. So we do have proteins, which are hormones, or kind of like a hormones, but you call it as a receptor. um okay, but same concept. It's just a different molecule. So steroid hormones are mostly a cholesterol derived molecule. um you can have a few reactions to form it. Biologically, it's very easy, I would say, but chemically, depends. I guess some hormones are easier to synthesize than others. All right, so sex hormones, for males, normally you have a high level of testosterone and androsterone. For female, you have estrogens and progesterone. But that doesn't mean that if you're a male, you don't have this. Okay, it's not true. You do have a little bit of estrogen and progesterone, but it's more the major component is this for each sexes. Okay. um and others, you have adrenal corticosteroids from the adrenal gland. Adrenal gland is located just above your kidney. So when you have your kidney beans like that, so adrenal gland sits on top of your kidney. All right, so it produces mineralocorticoids for electrolyte balance, and glycocorticoids, which is part of glucose level regulation. And just as an example, testosterone and estrogen, you can see the structure is more or less similar. Okay, you have one significant difference there, you have two over there, you are missing the methyl group over here, but everything else is the same. So pretty much it's almost identical. All right, so I think that's the basic for steroid hormones. Just the basic structure. This is the basic structure for any steroids. Okay, so you have a 6-membered ring and three 6-membered rings and one 5-membered ring, connected to one another, and the backbone will look exactly like this. So you don't have suddenly a 5-membered ring over there. So that does not happen. So if you do see that, that one is not a steroid. A steroid characteristic is to have this 4 cyclic membrane arranged in this particular manner. All right, so let's look at the health effects, or how to link steroids to health. So the first one, we're gonna look at lipoproteins. So we didn't cover anything about lipoproteins, but lipo is the fatty acid component, right, or the lipid component that we've just talked about, and proteins is what we've been learning about for the past 4 weeks, 6 weeks, or 4 weeks, more or less. Okay. So what are lipoproteins? Lipoproteins surrounds non-polar lipids with polar lipid and protein, which is lipoprotein. Actually, so it's a polar lipid and protein for transport to cells. So we do need to have a non-polar lipids. So imagine if you eat chicken fat, for example, or chicken skin, which contains a lot of fat. So, and fat is insoluble in water. So how do your body actually transport this into your system? How do they transport it throughout your body? Because every cell needs to have a non-polar lipid as part of the component. So how do you transport it? So you transport it using a polar lipids and a protein, which is also called as lipoprotein. Okay, so it makes a non-polar lipid soluble in water and aqueous. And this is an example of a lipoprotein. So what you have here is, for example, if you have the inner core of cholesterol ester and triacylglycerol, which from the previous lectures that they are very, very hydrophobic. All right, so to transport it, you have an outer core of lipoprotein. Okay, so you have lipids and the proteins. Of course, this protein can also be a receptor, so that cells know, okay, this is a lipoprotein. So if we need lipoproteins, or sorry, if we need lipids, then you detect these proteins on the surface of lipoprotein, and then digest it or engulf it, and then process it as your own. Okay, so that's how basic idea on how, well, the importance of lipoproteins to health. Okay, for example, again, cholesterol, you do have cholesterol in the body. So how do you transport from the cholesterol that you synthesize or you eat into your cells? So this is how we do it in a general perspective. Obviously, it's by no means this is very specific on how the transport system works. All right, so other things about lipoproteins that you might have heard before is the word LDL and HDL. So low density lipoprotein and high density lipoprotein. Um, so that's what LDL HDL is. So if you have ever encountered a poster about LDL HDL, now you know that it is actually a lipoprotein and how it looks like and what are the functions, or at least the general terms. Okay, so lipoproteins differ in density, composition, and its function. So you have the LDL and HDL, and table 15.5 are actually showing you the composition and properties of a plasma lipoprotein. All right, so the main differences is the cholesterol level. As you can see here, the low density lipoprotein has a higher cholesterol level, and the high density lipoprotein has a lower cholesterol level. So that's why when you, if you have, sorry, if you have heard about LDL and HDL, you normally heard that LDL is bad for your health. LDL is bad for your health. HDL is good, so you need to consume more HDL and whatnot. So this is part of the reason. Okay, so you don't want to consume a lot of cholesterol because your body has already contained a lot of cholesterol. Other than that, it's more or less identical. You have lower proteins over here, but again, that's because of a function. All right, so a high concentration of LDL promotes arteries blockage from clot formation, as I've shown in the past few slides. So linkage to health, number two, the best thing, or what everybody probably have heard of, is anabolic steroids. It's a derivative of testosterone. It's normally used illegally to increase muscle mass, and the side effects of consuming anabolic steroids are such as fluid retention, retardation in hair growth, sleep disturbance, liver damage, and so on and so forth. So these are some of an example of anabolic steroids. Again, if you looked at the naming, something own, right? Something own, something own, something all, right? So all and own are the basic naming structure for steroids. So in the future, if you read something, a label containing whatever fancy name, and towards the end of the day there's an all or ONE, then you know that, well, it's a steroid. So you might want to check about the ingredient, because it can affect a lot of things. All right, so linkage to health, number three. So adrenal corticosteroids. So it produces in the adrenal gland, as shown here. Okay, so that's your kidney, and on top of your kidney you have adrenal gland. It produces two different types, or not just two, different types of corticosteroids. The first one is aldosterone, which regulates electrolytes and water balance by the kidney. Okay, so kidney functions to regulate water, hemostasis, homeostasis, if you have not heard about this. So homeostasis means biological balance, in a simple term, biological balance. So it controls the hemostasis, or it controls the balance of water in your body by the kidney. So it's a water hemostasis. That's the terminology that biology uses. All right, and then other than that, you have cortisone, which is a glucocorticoids. So it increases blood glucose level and stimulates synthesis of glycogen in the liver. So even though, so it's pretty much work hand in hand with insulin. Okay, so insulin, which is a protein, as mentioned, it controls the glucose level in the body. Okay, but when you talk about this, what you have is glucose. We're talking about biology a little bit. Okay, glucose and glycogen. So you have insulin. Oops, insulin to break glycogen to glucose. Or is it the other way around? Stimulate synthesis of glycogen. Yes. Okay. And then you have glucose and you have over here cortisone, which promotes the formation of glycogen from glucose. So these two molecules, so even though one is protein, so that's very interesting, isn't it? One is a protein, and one is a steroid, but they work hand in hand to actually control the homeostasis of a sugar in our blood. Okay, so again, unbalanced level of this, either glucose or water, can result in side effects. So that's why even if you drink a lot of water, drinking a lot of water is fine, but drinking excess of water can actually kill you. These are some references that we are using. Okay, pretty much most of the figures comes from Pearson. And a short revision for lipids. Um, question one, identify each of the following as fatty acids, starch, or triglycerol. So just try and do it on your own. And if you have an issue in trying to identify it, let me know. Then we can discuss about it on Thursday. Okay. If nobody asks about this in Thursday, I assume that everybody knows this, right? Question number two, match the components of cholesterol molecule with the following. So carbon chains, steroid molecules, nucleus, sorry, hydroxyl group and methyl group. If you're a chemist, I expect that everyone can do this. If you can't do it, please talk to me. Okay. All right, that's it. Thank you for being a good sport. And finally, I have put in so if you go to Spectrum, specdrem.um.edu.my. Okay, if you go to Spectrum, you log in, what you can see is I put a link for a course exit survey. Let's go to, where's the subject? This one. Okay, so I've put it here, an exit survey. All right, so please complete this exit survey if you can. It will be good for especially for me and Dr. Aziana to have a good feedback from you guys and to see how our online, well, almost fully online semester works, and what are some suggestion. I welcome any other suggestion on how I might want to improve my lecture. Okay, so I know some people likes to watch a pre-recorded lecture because I like to do that. But there are also complaints from um, I don't think it's from chemistry, but there are some complaints from some of your friends saying that a lecturer posts pre-recorded lecture and then give out lecture notes very early before the scheduled lecture and whatnot. So yeah, so but by all means, just let me know if you have any issues. Let me know if there's a way that you, as a 10 years younger than me, I'm not saying that I'm old, but you might want to have a lecture a completely different style. I don't know, probably um, put it in TikTok or something. Like, I'm just joking. But yeah, just let me know, okay? And put it in the survey there. If I'm not mistaken, there should be a section where you can write something. So please help me to help your juniors. That's it. Thank you, and see you on Thursday. Bye.